Derivatives of trigonometric functions. So far, we've talked about taking derivatives of many types of functions with various rules. But what about when none of those rules apply? For example, if we're asked to take the derivative of y equals sine of x, how would you go about doing that? The great thing about trigonometric functions is that their derivatives are easy and simply require some memorization. Below are the derivatives of the 6 trigonometric functions. A way that I remembered what these derivatives were actually had to do with their connection to one another with the Pythagorean identities. For example, sine squared of x plus cosine squared of x is equal to 1. That's one Pythagorean identity. And the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. Similarly, another Pythagorean identity that we learned about in pre-calculus is 1 plus tangent squared of x is equal to secant squared of x. So I made that connection between tangent and secants with the derivatives. The derivative with respect to x of tangent of x is equal to secant squared of x. And the derivative with respect to x of secant of x is secant x tangent x. Similarly, the last Pythagorean identity with trigonometric functions is 1 plus cotangent squared of x is equal to cosecant squared of x. So the derivative of cosecant of x is negative cosecant x cotangent of x, and the derivative of cotangent of x is equal to negative cosecant squared x. So that might be a way to help you guys remember the derivatives of these different trig functions that we have. And we're going to use these along with our other derivative rules to find the derivatives of more complex problems involving trigonometry. There are proofs on how and why certain rules work for trigonometric derivatives, and you can access them using these links if there's an interest. So we have a proof of the sine derivative, a proof of the tangent derivative, and the proof of the cosecant derivative. These proofs can also be found in the appendix of this presentation. Let's try an example. Find the derivative of f of x, which is equal to cosine of 2x plus 3. First, we have to set up the chain rule with cosine of x being our outer function and the 2x plus 3 being the inner function. So first we take the derivative of cosine, which is negative sine. We keep the angle equivalent to what it originally is, and then by the chain rule we take the derivative of that angle. And this is what we have. Then the solution simplifies to be negative 2 sine of the quantity 2x plus 3.